Today in lab, we're going to be doing two different types of distillation, simple distillation and fractional distillation. And you'll be working with a partner today, so you will do one of those two and your partner will do the other. What we're looking at here is a simple distillation setup. A few things that I want to point out is, number one, the level of your thermometer is very important. So here I've got the bulb of my thermometer below this joint right here. It's very important to get an accurate temperature reading. Additionally, you want to have a O-ring holding that thermometer in place, and you want to make sure that this is tightly sealed at the top. For your condenser, you want to make sure that the hoses are pointing up and that the water is flowing in from the bottom and out through the top of your condenser. This piece over here is actually optional. It's nice because it directs the flow of your distillate really nicely, but it's not totally necessary, and I'm actually not going to be using it, which you'll see in a little bit. Here we've got our fractional distillation setup, and the only difference between this and the simple distillation setup is that now we've got this fractionated column added in. And that column's got steel sponge packed inside of it. And basically what that's going to do is it's going to help separate out the different compounds in our unknown mixture. So one of the challenges of doing a fractional distillation is keeping this column insulated. So what you can do is you can grab this PVC tubing and wrap that around the column to insulate it. Okay, so I'm ready to start my simple distillation. I've got my water flowing gently through my condenser. I've got 8 milliliters of my unknown mixture in my round bottom flask, and I've set my temperature on my hot plate to 200 degrees just to get started. That's something that I'm going to monitor as we go. Additionally, I've used a wooden block to lift up my hot plate just a little bit so that the level for my graduated cylinder is more convenient. After 5 minutes, I can see that my solution is now boiling. The key here is I just want to keep monitoring what's going on with the distillation and watching that temperature. Here I can see my solution condensing and then dripping back down into my reaction flask. So it's been about 7 minutes since I started heating, and I can see that my solution is boiling, and the temperature on my thermometer has gone up to about 75 degrees. And in fact, I'm just getting my first drips of distillate coming off and collecting into my graduated cylinder. In terms of monitoring this distillation, every time you collect half of a milliliter of distillate, you want to take a temperature reading. So I'm at 1 milliliter and my temperature is now 75 degrees. Also, since I'm at 1 milliliter, it's time to take my first sample for GC analysis. So this is my GC vial, and I'm just going to collect 3 to 4 drops into this vial. I've now collected 5 milliliters of distillate, so it's time to take another sample for GC analysis. Now, even though I've collected my 2 samples, I still want to continue with the distillation until it's gone to completion and monitor the temperature throughout that entire process. My distillation is now complete, so the best thing to do is simply raise your distillation up off of the hot plate to let it cool, and go ahead and just turn your hot plate off. The last thing you'll need to do to prepare your GC samples for analysis is simply fill the vials up to the 1.5 mark using dichloromethane. So we'll have a squirt bottle of dichloromethane available for you to do that right before you put them in the tray for collection. Once your GC data is available, you'll have to download that, and I'll try to make a little video later this week showing you how to analyze that data.